Now we see the most important component in galvanic cell is solbrief. What is the solbrief? So solbrief contains a solution of non-reacting ions such as potassium chloride, potassium nitrate, and sodium sulfate. They have the two functions of solbrief. First, solbrief to maintain the electrical neutrality of the cell, and the second act as a liquid wire, allowing ion to flow and complete the circuit. This is a diagram of the solbrief and the position of solbrief to connected between two containers. How does the cell maintain its electrical neutrality? So these are the two reactions, first at the anode and second at the cathode. At the anode, student can see half reaction for the zinc. From zinc solid produce zinc 2 plus ion and the lost 2 electron. So after the reaction, zinc 2 plus ion enter the solution, causing an overall excess of positive charge. At the anode, the solution excess of the positive charge. At the cathode, student can see half reaction for the copper. So copper 2 plus ion gain 2 electron to become copper solid. Copper 2 plus ion leave the solution, causing an overall excess of negative charge. At the cathode, the solution excess of negative charge. For your information, solbrief a solution of non-reacting ion, example potassium chloride. In potassium chloride have the potassium ion and chloride ion. Chloride ion from the solbrief move into the zinc half cell, so to neutralize excess of positive charge, and potassium ion from the solbrief move into the copper half cell to neutralize excess of negative charge. After solbrief take part to neutralize excess of positive charge and negative charge, so electrical neutrality is maintained. What happens if there is not solbrief in our galvanic cell? So student can see this diagram without solbrief. In galvanic cell, electron flow from the anode to the cathode. At anode, zinc electrode will dissolve to produce zinc 2 plus ion. At one time, the concentration of zinc 2 plus ion in this solution increase. So in our galvanic cell, the reaction stop because the net increase in positive charge is not neutralized. This excess charge can be reduced by adding a solbrief. That is the function of solbrief in our galvanic cell. How to write the cell notation? This is the one example how to write the cell notation. From the cell notation, student must be know anode oxidation on the left and cathode reduction on the right. Second, the single slash represent phase boundary. Like example, at the anode, separate between phase solid and phase aqueous, and at the cathode side, separate between solid electrode and aqueous solution. Double slash represent solbrief, so solbrief at the middle to separate between anode and cathode. And last one, electrode appear at far right and left of notation. Anode stand for the zinc electrode, and at the cathode stand for the copper electrode. So student must be remember single slash for components that are in different phase. Example, solid to split between aqueous phase and gas phase. So student must be use single slash. And second example for the cathode is hydrogen. So solid phase not split with the gas phase and aqueous phase, so using the single slash. Use comma for components that are in same phase in our cell notation. Like example, you have the aqueous phase and aqueous phase and aqueous phase, so put the sign of comma. For the remainder, after student write the overall equation, to write cell notation, don't put coefficient of the overall equation in our cell notation. The last for 3.1 galvanic cell, student must be know about standard electrode potential in not half cell. What is a standard electrode potential? So standard electrode potential, a measure of the ability by a half cell to attract electron toward it at standard state. For the standard state, the gas mixture must be 1 atm pressure. For the solution, make sure 1 molarity concentration, and the electrode must be pure solid. The magnitude of the electrode potential depends on the tendency of the metal or non-metal to lose electron. So E0 half cell can be E0 anode or E0 cathode. For your information, electron flow from the anode to the cathode because there is a difference in electrical potential energy between the electrode. Like example, we have the zinc copper cell or galvanic cell, so it is impossible to measure the absolute value of an electrode potential directly. So the standard hydrogen electrode She is used as a standard reference to measure the electrode potential of other half cell. For your information, the standard hydrogen electrode, the value E0 She equal to 0.00 volt. This is the diagram for standard hydrogen electrode She. So for She, platinum electrode must be immersed in 1 molarity aqueous solution of strong acid through with hydrogen gas at pressure 1 atm. So student must be remember hydrogen measure pressure 1 atm. The aqueous solution measure concentration 1 molarity for the strong acid. Must be used platinum electrode of graphite electrode. And for your information, She can be anode of cathode side. So the value of the standard electrode potential of She equal to 0.00 volt.